One of the foremost things of the primary requirements of the humans is here. Lack of here, most specifically lack of oxygen, leads to hypoxia. Hypoxia was first reported in high altitudes on the mountains by the mountain climbers, and then after the invention of the aircrafts, pilots and flight attendants are also experiencing hypoxia and they are feeling stressed. As a general term, hypoxia can also be termed as the decompression sickness. Decompression sickness was first identified in the year of 1841 by the miners, the people who were working deep in the ground and working hours and hours in the mines. They were feeling dizziness and giant pains. So the effect can occur in reverse to the pilots who fly in high altitudes. Normally we fill the cabin by the compressed and pressurized here just to have a comfortable environment, to bring a comfortable environment for the pilots, for the flight attendants, and also for the passengers. But the problem comes with the percentage of the oxygen. While we fly at high altitudes, it's obviously clear that we have an environment of the normal pressure for the occupants, but we cannot provide enough percentage of oxygen in the cabin, so we normally breathe not enough percentage of oxygen, which is normally needed for the normal metabolic activities of the body. The symptoms of hypoxia are not the same in all pilots. This means that if we consider two pilots or two flight attendants or even two passengers, so they cannot catch the same symptoms of hypoxia. It differs from person to person, and strongly it depends to the gender. The person is either a man or woman. It depends to the age, to the physical fitness of the body, and also it depends to the lifestyle of the person. Either the person is a normal alcohol consumer, or the person is a smoker, either a normal smoker or very heavy smoker. So these factors play a very important role to the symptoms of hypoxia that we can catch while we are subject to an environment of the low oxygen percentage. So to understand the better relationship between the percentage of oxygen and atmospheric pressure, so let me continue my presentation by presenting you a very simple example. In this simple example, we consider a healthy person sitting inside of a room, and we have normal percentage of oxygen, or the room is full of the normal percentage of oxygen, which is the 21%, because we know that atmosphere consists of the different gases, and 21% of atmosphere consists of the oxygen. And then we have normal atmospheric pressure in the room as well. So in the first scenario, we reduce the percentage of oxygen, or we bring down the percentage of oxygen from let's say 21%, which is quite normal, to 18%, then 17%, then 10%, as long as we keep the atmospheric pressure constant, the same in the room. So once the percentage of oxygen is brought down to the lower percentages, our lungs will not be able to absorb enough amount of the oxygen, which is normally needed for our normal metabolic activities of the body. So once the lungs cannot absorb enough amount or enough percentage of oxygen, the blood circulation will not be able to transport oxygen to all our lungs, including the mind. So what happens? We start to catch symptoms of hypoxia. So as we said before, it depends to the physical fitness, to the age, to the gender, and to lifestyle of the person who is sitting in the room. If this condition continues, so the person will go deeper and deeper to the symptoms, and finally he or she will be led to death. Now in the second scenario, we again bring the percentage of oxygen back to the normal, which is 21%, and now we reduce the atmospheric pressure gradually. So once the atmospheric pressure is reduced to significant lower values, Now we see that our lungs again will not be able to absorb enough percentage of the oxygen, and symptoms of hypoxia will start to that person's body. Even though the person is breathing or inhaling 21% pure oxygen, but since there is not enough atmospheric pressure, the lungs will not be able to absorb enough percentage of the oxygen, and the symptoms of hypoxia will start. So this means there should be a relation between the percentage of the oxygen and the atmospheric pressure. If the percentage of oxygen, for example, goes lower from the normal, which is 21%, the atmospheric pressure should be kept constant. So this way, what we do, we force the lesser percentage of oxygen in the lungs and force the lungs to absorb that lesser amount or lesser percentage of oxygen. Or if the atmospheric pressure goes lower and lower, so the percentage of oxygen should be kept to the constant level or the standard level, which is the 21%. So this relationship between the percentage of oxygen and the atmospheric pressure is very important while we fly in high altitudes. For example, let's say we are in the sea level, and that's on a standard day, and temperature is 15 degrees Celsius, and we have normal atmospheric pressure, which is 1013 millibars or 29.92 inches of mercury, and then we have normal air density, and we have normal 21% of the oxygen. As much as we for example, go higher and higher from the sea level, the main three characteristics or factors of the air will reduce. And what are they? The temperature, the pressure, and the density. So the temperature of the air, the pressure of the air, and density of the air will reduce gradually as much as we go higher and higher from the sea level. So what happens with the percentage of oxygen? Same as the air factors that we talked, the percentage of oxygen will also gradually reduce. So let's say we are flying in a commercial airplane without having the pneumatics and pressurization system, and we plan to take off from the sea level while we are experiencing standard day and climb and level off at 20,000 feet mean sea level. Now let's examine and see what will happen. Once we take off, as we said before, as much as we climb higher and higher, because we do not have any system to control the temperature, to control the pressure inside of the cabin. So whatever characteristics the air has outside of the airplane, so same characteristic will be inside of the airplane. Once we level off at 20,000 feet, the temperature, the pressure, and the percentage of oxygen inside of the cabin will be quite the same as they are in the outside. So obviously we know that this condition or this atmosphere inside of the cabin is not sustainable. It is not something that we can survive or we can continue with our normal tasks and duties. We will catch hypoxia. There will be plenty of the other problems like low pressure, low temperature, and in fact all occupants will be led to death. So what to do to control this condition or this situation? Among the three things that which are very important for us, two of them are controllable and we can control, but one of them is uncontrollable, we cannot control. So the things that we can control, the factors that we can control to bring a comfortable environment for the pilots, for the flight attendants, for the passengers, are the temperature inside of the cabin, in fact, the pressure inside of the cabin, but the only factor that we cannot control is percentage of oxygen. But as we talked before in our very simple example at the beginning of our presentation, that we said we put a person in our example sitting in the room. In one scenario we reduced the percentage of oxygen and kept the atmospheric pressure normal. In second scenario we brought the atmospheric pressure down to lower, for example, levels, so lower values, and then we kept the oxygen percentage normal. Same thing will happen in our commercial airplane, which is now stabilized in 20,000 feet. So for the aircraft designers, they have tried as much as possible to make the cabin environment comfortable for all the occupants. It's not only a matter of the pilots and the flight attendants, but for the passengers as well. We need to have a comfortable environment, or comfortable cabin, in fact. So in commercial airplanes, we have a pneumatic system. What does pneumatic system do? The pneumatic system gets the air, or sucks the air from the engine compressor. In fact, the engine's compressor, if you have two engines like a Boeing 737 Classic, so from left engine, then from the right engine, both, because we have two systems, left and right, and from different stages of the compressor, which depends to the aircraft model and to the engine model. Then the air that we get from the engine compressor is very hot and with a high pressure, which is, in our technical terms, we call it blade air. So the blade air will be taken from the engine compressor. Then the pneumatic system has another system which is called the pack. So the air flows inside of the pack just to reduce the temperature to a comfortable level. Now we can select which air temperature we need to become inside of the cabin. Either we need a cold temperature, warm or hot, whatever. So once the temperature is regulated, then this regulated temperature and high pressure air is blown inside of the, or pumped inside of the cabin. Now the pressurization system function starts here. So what does the pressurization system do? The pressurization system just lets more amount of the air to be pumped inside of the cabin and less amount of the air to be exhausted overboard by the outflow valve. So once the cabin pressure or the pressure inside of the cabin reaches to a normal value, and then the pressure tends to go higher than the normal, the pressurization system will modulate the outflow valve more open and will let more air to escape overboard, just to bring the pressure down to a normal level. And if the pressure inside of the cabin tends to become lower, then the pressurization system will modulate the outflow valve towards closed position in order to bring back the pressure to the higher level, or back to normal in the cabin. So this is something, some play of the pressurization system by modulating the outflow valve open, close, semi-open, semi-closed, just to keep the pressure to the normal inside of the cabin. Mostly for the safety purposes. Almost most of the commercial airplanes are equipped with the pressurization system, and the pressurization system mostly have three other subsystems. Mainly the first system of the, or subsystem of the pressurization, is the automatic system. In the automatic system, everything is controlled automatically. There is nothing to play with for the pilots. Automatic, everything is performed. Only some setting is required, which the pilots are doing while the plane is on the ground before the departure. For any reason, if the automatic system fail, or there is a problem with the automatic pressurization system, the system will automatically transfer to the standby. Standby system is a semi-automatic. So in standby, pilot needs to put some settings, or to change some settings in the pressurization, and then again it will start functioning automatically to keep the pressure and constant inside of the cabin. For any reason, if the standby system also fails, now the pilots will transfer the system to the manual, and now even though the workload will increase, but anyhow pilots are able to still control the pressure inside of the cabin by manually modulating the outflow valve towards open or closed. So once the pressure inside of the cabin is normal, lesser percentage of oxygen which is absorbed by our lungs will be something normal. We cannot say quite normal, but it's going to be something normal. Even though if we fly in high altitudes for hours and hours and we feel relaxed, for example, we say, okay, we are not stressed, we are relaxed, we can do our tasks and jobs normally. But believe it or not, as pilots and flight attendants, we are normally working in a hypoxia environment. Now, to better understand why we are, as pilots and flight attendants, are normally working in a hypoxia environment while we are flying in high altitudes, let's consider we breathe or we inhale the normal percentage of oxygen, 21%, without atmospheric pressure. So the design of the lunges is such that 21% pure oxygen without atmospheric pressure will flow inside of the lunges, but the lunges will not be able to absorb. So there should be a force just to force the oxygen molecules to be absorbed by the lunges, and then the lunges will attach the oxygen to the blood, and the blood will transport oxygen to whole body. But if this pressure goes higher and higher, as long as the percentage of oxygen is lower and lower, again we'll have problem, because lunges will not have something needed to be absorbed. For example, from the sea level up to 18,000 feet, let's say, the atmospheric pressure of the air reduces to half. So if we have, for example, let's say 30 psi pressure in the sea level, which is slightly higher than the normal, and then we climb to 18,000 feet, 18,000 feet, and we, for example, see the atmospheric pressure, we will be experiencing 15 psi pressure in the 18,000 feet altitude. Unfortunately, as we talked about the three factors, the only factor which is not controllable is the percentage of oxygen, and we do not have any machine or any generator in the aircraft to produce more and more oxygen and pump the oxygen inside of the cabin, just to, besides having the normal pressure, to have a normal percentage of oxygen for all the occupants, for the pilots, flight attendants, and passengers. But what we do, since lesser percentage of oxygen is there, we keep the atmospheric pressure to normal in order to help the lunges to absorb as much oxygen needed. But anyhow, we catch 1 or 2 symptoms of hypoxia while we fly in high altitudes for hours and hours. For most of the companies, and for the safety purposes, they perform some periodic tests, medical tests on the pilots and flight attendants. Just they want to make sure the physical fitness and strength of the bodies of the crew, the flying crew. So what they do, they perform test before the flight, and after the pilots and the flight attendants fly hours and hours in the high altitude, and at the end of the flight they again perform a medical test on the pilots and flight attendants, and they record which symptoms of hypoxia was caught by the pilots and by the flight attendants. If significant symptoms were caught by the flight crew, the nominated flight crew will be subject to home rest with some medication, just to help him or help her to have better and better strength of the body to fight against the symptoms of the hypoxia. So among the different symptoms of hypoxia, we can name some of them. For example, we can have the change of the color in our nails. We can have headache, stomachache, backache, pain in our chest, and the rate of the heart, pumping of the blood by heart, will be increased. Then we can have problem with our vision, and we can have forgetful and disturbed sleep, and besides all, we will not be able even to perform the life-saving tasks. Hypoxia is very dangerous for the pilots. Why? Because if we catch the first symptom of the hypoxia, our body still will act normal. We feel still comfortable, we feel still relaxed, and there is not any alarm in our body to call us that, hey, you have got hypoxia. But once we go deeper and deeper in the symptoms, so our performance will be reduced. We will have problem with our vision. We will feel some pain in our head and maybe in the back, in the chest, and the blood pressure will increase, and we will have forgetful. We will not be able to remember the procedures recall from our mind, because our mind normally needs oxygen. So if there is lack of oxygen in our mind, so these symptoms will be just brought in our body, and then we reach to a stage that we will not be able to perform our tasks. Amongst all, I think it's beneficial if we know what our body does with the oxygen. So once we breathe the air, once we inhale the air, our lungs will be full with the air. So what does the lungs do? Since the percentage of oxygen is with the normal amount of the atmospheric pressure, our lungs will absorb the oxygen, and then oxygen will be attached to the blood, and the blood circulation will transport oxygen to all our body tissues, including the mind. Once the level of the oxygen or the percentage of oxygen reduce, so all tissues will send signal to our mind and will ask the mind to do something so that they can get more and more percentage of the oxygen. The only part of the body that the mind can signal is the heart, because mind cannot do anything with the lungs. Our mind will signal the heart in order to pump the blood more and more and more. So the only way for the heart to pump the blood more, to make a more circulation in the body, to transport more percentage of oxygen for our body tissues, is to pump the blood as fast as possible. So this is why the blood pressure will increase, and if we have some problem with our heart, there will be mostly the problem of the our heart to stop functioning. So this is why we immediately go to some deeper symptoms, and at the end, if we cannot supply extra oxygen to our lungs, we'll go to death. Now let's talk again about the pressurization system and what happens during the flight in high altitude if we get problem with the pressurization. As we said before, till now we know that the lesser percentage of oxygen in high altitude will be compensated by keeping the atmospheric pressure inside of the cabin as normal as possible. Mostly in the aviation terms and technical wording, we are not only calling the pressure inside of the cabin as cabin pressure, we call it cabin pressure altitude. Why? Because, okay, for example, we are flying at an altitude of 20,000 feet, but the pressure inside of the cabin is not the same as the pressure which is in the 20,000 feet altitude, or let's say flight level. Because of this, we are not calling it only cabin pressure, we call it cabin pressure altitude. We keep the pressure inside of the cabin to a pressure which is in the lower altitudes, mainly in 8,000 feet, for example. So once we stabilize in our cruising altitude of 20,000 feet, the pressure inside of the cabin will be the same as the pressure which is in the 8,000 feet altitude. Because of this, we call it cabin pressure altitude. As much as we climb higher and higher, we need to increase the cabin pressure, but the cabin pressure altitude will also increase. This is a proportionality between the altitude and the cabin pressure altitude. Then as much as we descend lower for the landing, we depressurize the cabin gradually, and finally at touchdown we will have zero differential pressure, but we still keep slight amount of the pressure, which is 0.125 psi, just for the comfort of the passengers. So the problem is what happens if we lose the pressure during the flight. Because if we lose the cabin pressure during the flight, we lose one of the important factor, which is a life-saving factor for all the occupants, for the pilots, for the flight attendants, and for the passengers. If we lose the pressure, we will not be losing the percentage of oxygen. By all means, the percentage of oxygen will be the same as long as we have flow of the air inside of the cabin. But if we lose the pressure, so obviously our lungs will not be able to absorb enough percentage of the oxygen. The first and immediate task that we should do is to have supplemental oxygen, to have extra oxygen to be inhaled in our lungs. So the first and immediate action will be to use the oxygen mask or wear oxygen mask, and we have the systems in the aircraft to supply oxygen for the pilots, flight attendants, and passengers. For the pilots, we have quick donning oxygen mask. Mostly the oxygen mask for the captain is located in the left side, and for the first officer in the right side. Then we have an oxygen mask for the observer who is sitting in the back seat. And also the pilots need to quickly don the oxygen mask and start inhaling or breathing the oxygen, just to let them perform some life-saving activities. And what will be the life-saving activity? To descend to lower altitudes. Same, we have the oxygen masks for the passengers. So, and mostly Boeing 737 Classics, we have 3 masks which will be dropped from the PCU or passenger service unit. For each triple seat we have 4 masks which will be dropped down, and once you pull one of the masks and wear it, then there is an oxygen generator, and the generator will be activated, and it will supply oxygen for almost 12 to 15, in most cases to 20 minutes. So 20 minutes time is quite enough for the pilots to perform a life-saving activity. And what will be the life-saving activity? To descend to lower altitude, to bring the aircraft to an altitude where the air pressure, air density, and percentage of oxygen is higher than the previous altitude which the airplane was cruising. Same, we have oxygen mask for the flight attendants stations, and we have 2 masks which will drop in each lavatory. Why 2 masks? Because maybe there is a lady with her baby inside of the toilet, just to wear the mask for herself and for the baby. So mostly we experience 2 types of the pressurization system problem. The first problem is that we lose the pressure gradually. So this is not something to worry about, because the pilots will immediately catch this problem. And as we said before, there are 3 mainly subsystems of the pressurization, and if one system does not work properly, then the second system will start functioning. If the second system does not work properly, then there is another backup manual system that the pilots will transfer the system to the manual, start to control the pressure inside of the cabin. And if all these 3 subsystems fail to control the pressure inside of the cabin, the pilots have plenty of just time to gradually descend to lower altitudes. But by all means, it's not an emergency descent, it's a normal descent to lower altitudes, and we inform the ATC that we have pressurization problem and bring the aircraft down to a safe altitude where we have the more percentage of the oxygen, air pressure, and density, and to control the or to make the environment back to normal for the passengers and for all the occupants. But the main problem, which is going to be an emergency, is that if we lose the cabin pressure in a very fast manner, which is called the decompression. So what happens if we experience decompression? What does decompression here means? That immediately we lose the pressure inside of the cabin. That happens, for example, a passenger window bursts, or maybe there is some problem with a part of the fuselage, and a part of the fuselage blows out due to any reason, maybe the weakness of the fuselage, maybe due to a crack in the fuselage. Because we all know that once we keep the pressure inside of the cabin normal, as long as the pressure outside of the cabin is lower, so the fuselage is under stress and pressure from inside. So if a window bursts or a part of the fuselage, for example, blows out, now what problems we will experience? The first problem will be that the air with high pressure inside of the cabin will rush towards that opening. So all loose objects in the cabin will be blown out from the aircraft, even the passengers, and there will be plenty of noise inside of the cabin. And another major problem will be that the visibility will be reduced. There will be fog inside of the cabin. Why? Because we keep the temperature inside of the cabin almost to 22 or 23 degrees centigrade, as long as the temperature outside of the cabin is almost to minus 45 degrees centigrade or minus 50 degrees centigrade. So this will cause the temperature inside of the cabin to immediately come to lower degrees, and this immediate cooling of the air inside of the cabin will produce just fog inside. So this is a real emergency. So in this case, the pilots need to perform an immediate emergency descent to lower altitudes. So the first and immediate thing which is needed is oxygen. So everyone needs to wear the oxygen mask, including the pilots and the flight attendants, and then the pilots to perform an emergency descent immediately to lower altitudes in order to control the situation. So obviously, as passengers, while you're flying in the commercial airplanes, you will see that lovely people are there to give you safety demonstrations. And among the safety demonstrations, there will be some demonstrations how you can use the masks. So our flight attendants are making you ready, just to make your mind ready for this type of the circumstance or situation if happens. So it's not going to be something very amazing for you that what are these for example, masks dropped from the above, from the PCU or the unit which is above the passenger seats. Strongly it is recommended that some procedures and some recommendations should be followed. And among these recommendations, let me see the list for you, and I am going to there are almost 5 basic recommendations for such situations. And the first one reads, it's necessary to provide oxygen and pressure in the cabin of the pilots to increase their decreased endurance due to decompression and hypoxia. And the second recommendation is to deal with hypoxia. Systems should provide oxygen for breathing, as we said before. The third recommendation reads, to deal with the decompressed atmosphere, the system should provide pressure in the cabin so that the pilots can work in normal atmospheric pressure conditions. And the fourth one reads, it is necessary to examine the pilots for their physiological conditions once in a stipulated period to find the negative effect of hypoxia on them, if any, as we explained. And the fifth recommendation, there should be situational arrangements in aviation industry to deal with the decreased physical endurance of the pilots. So colleagues, thanks much for watching the video. That was a short presentation regarding the oxygen and the effect of the hypoxia, and what we will do as pilots and flying crew to save the passengers and save the airplane in case of rapid loss of the pressurization system. And I hope watching the video will increase slightly your general knowledge of the flying, because I'm sure plenty of times it happens that we should fly by the airplanes to our destinations. And that's worth to mention that we hear from some of the people that pilots and flight attendants and even the passengers are breathing artificial oxygen while they fly in the airplane, but this is totally wrong. During the flight, we are not breathing artificial oxygen. We breathe pure and normal oxygen. which is in the outside of the aircraft, but because the percentage of oxygen is less, to help the lungs absorb more and more percentage of the oxygen, which is normally needed for the metabolic activities of the body, what we do, we keep the pressure inside of the cabin as normal as possible. But if we lose the pressure, for example, gradually, we have procedures for it. If you lose the pressure inside of the cabin very fast, like the decompression, so still we have the procedure for it to save the passengers and save the airplane. Thank you, and any question, please leave in the comment box of this video. In time available, we'll discuss about it.